This week we'll be solving problems using Charles' law. So I'm going to write Charles' law at the top, which is V1 over T1, which is equal to V2 over T2. Remember, V is volume. Wow, look at that. Is volume, and T is temperature. But the temperature must be in Kelvin. So we have a sample of neon gas, and it occupies a volume of 752 milliliters at 25 degrees Celsius. What volume would the gas occupy at 50 degrees Celsius if the pressure remains constant? So we know V1 is 752 milliliters. And T1, the temperature, is 25 degrees Celsius. But in order for me to turn into Kelvin, we have Celsius plus 273. That's going to equal to Kelvin. So I'm going to add 273 to convert this into Kelvin. And 25 plus 273 is 298. And now the question asks, what would the volume be? So I'm solving for V2. If that temp increase to 50 degrees Celsius, so that's Celsius, I'm going to add 273 to it. I have to convert that to Kelvin, so 50 plus 273 is equal to 323 Kelvin. So now I just plug in my numbers into my formula. So V1, draw a line. So 752 milliliters over 298, and that's going to equal to V2, because we're solving for that, over 323 Kelvin. And now I'll do the butterfly method, where I multiply these two numbers and then I divide by 298 to get V2. So 752 times 323 is going to equal 298 V2. I multiply what's on the left times 2. 752 times 323, we have 243,219 equals 298 V2. I'm going to divide both sides by 298 to get V2 by itself. And then when I divide, my answer should be 816 milliliters. Okay. As you can see, the temperature went up, which means that the volume also went up. And that's what we know about Charles' law. As the volume increases, the temperature increases. Okay. Any questions, you should write me on Jupiter